My name is Shenxiong Zheng. I'm from Asia University, Taiwan. I'm also a board director of APNIC. So today, it's my great pleasure to chair the IPv6 Readiness Measurement Board. First of all, I'd like to welcome all of you to participate in this board meeting. And as you may know, the IPv6 Readiness Measurement Board is a platform for the government, for the organization to share the experience or current status of the development of IPv6 readiness measurement. And it's also the platform to discuss the measurement technology or measurement metrics. Today, I'm very happy we have invited 6 speakers from several countries. But for the sake of time, I'd like to suggest each speaker may have 12 minutes for presentation, and therefore we have 3 minutes for discussion. So the first speaker, is from Spain. Mr. Jordi Palet is going to talk about the IPv6 development status in Europe and the Latin American Caribbean.
Okay.
Jordi, please.
Yeah,
okay,
thank you. Just to give you an introduction, the reason I am talking about both Europe and Latin American Caribbean is because most of our work is not done just in Europe, but also in Latin America. I guess speaking Spanish, it helps a lot to get a lot of business and customers there, right? So let me start with Europe. Basically, what happened in Europe in the last years is that we had got a lot of governments that have big networks. Usually those countries, not all of them, but some of the European countries are so big and they have so different levels of government entities, like not just municipalities, but also districts, autonomies, or federal governments, or whatever you want to call, in addition to ministries, or and so, that it gets very complex and expensive if every entity make their own contracts for the ISPs. And also it's a question of security, managing data from citizens and so on, and changing data among different entities. So IPv6 give them an opportunity to get rid of a big issue that they have with IPv4 and private addresses and NATs, because they have a single network connecting all those institutions. And every time, typically every 4 years, when they change the government, maybe the ministry that today is Industry and Telecom, it gets split into ministries, in 2 different buildings, and they need to renumber the network, or they have problems with different layers of NAT and so on. So with IPv6, they don't have that problem anymore. So it was a very straightforward path to decide for those governments to move to IPv6. And in fact, some of these countries, I have participated in a few of them, for example, Spain, Germany, Netherlands, have even defined laws to mandate the public administration to move to IPv6. And I think this is very simple to understand. A network in the public administration is funded with the tax from all the citizens. So if you don't have a law and the people in the different public administration entities keep purchasing equipment or services or whatever, or ISP connectivity that is not IPv6 enabled, it means that, for example, a new router that should last 5 years maybe is going to last only 2 years because it don't have the right IPv6 capabilities. Okay, so this started already a long time ago. In fact, the law that I wrote for the Spanish government was published by the government in April 2011. That's the law number if you want to find it. There is a version published in English also. If you want to catch it, you will be able to Google for it quickly. And it included a plan for training all the engineers on the public administration. I did actually a tour across all the country, so I did 20 trainings for all the different governments, local, autonomic governments, how we call in Spain. We updated the CCTLD, the .es, to support IPv6. We had also an IPv6 website, is still online, IPv6.es. Unfortunately, that one is only in Spanish, but you can take a look. Which information for ISPs, for end users, for government entities, for enterprises about how important is the move to IPv6 and what steps they can take and some other information. And we did a lot of additional activities. I'm not going to go through all the list. You have them on the slide, but basically the idea was to make sure that we have the public networks ready for enabling IPv6 when the times come. Okay, so we started that job in 2011. Unfortunately, we had, in the case of Spain, a big economical crisis, so it was delayed a little bit. Then we had a problem to apply with RIPE for a policy to get the /24 that the Spanish government needed, and when the RIPE policy was adapted and the economical crisis is gone, then we are starting again or continuing with this deployment. Okay, but this is just one example. Several similar steps have been taken in other European governments as well. In fact, in December 2011, the same year I am talking about this Spanish regulation, the VP of the European Commission responsible for the digital agenda said something very important in a press release. The internet is doomed until European business and organizations begin to move towards IPv6. We are starting to see very close ahead of us the consequences if we don't make the switch to IPv6. So having politicians talking about IPv6, it looks like, why? This should be something really important, right? So it gives a message to the rest of the enterprises and citizens about the need to move to IPv6. Now, looking at the APNIC lab stats, just to have an idea about how all these efforts turned into reality, is not exactly, let's say, an even situation in all the countries, right? So we have some countries like Belgium, Germany, and some others smaller like Luxembourg, Greece, Switzerland, that got some quite good deployment of IPv6. So the movement from the government to support IPv6, in addition to the public administration, of course helps as well the ISPs in the country to go ahead, because if you want to make a contract with the government, you need to support IPv6, and typically you don't have a network for the government and a different network for enterprises in the country, right? So you really need to start providing IPv6 service. But these figures are basically for the results of what is the capability from citizens to access IPv6. So as a kind of summary for this, the point is, well, these efforts help, these efforts are needed, but the results may be not as quick as expected, because at the end it depends on private companies to deploy IPv6 or not. And I think that's something clear everywhere. In the case of Latin American and Caribbean, we have got a similar situation. I got hours awarded with contracts from several governments. I have them on the slide to work on strategic plans and laws for similar jobs, let's say, that what we did for the Spanish government. So the idea was making sure that public administrations are ready for the IPv6 deployment. And we get somehow a little bit more success here, especially, for example, governments like Peru or even Ecuador, and of course Brazil. In Brazil there is a big penetration of IPv6. And there are some other interesting cases. For example, I got a contract which one of the main ISPs in Guatemala. They have probably the bigger sharing in the ISP market in all the three sectors, in cellular, in corporate, and also in residential customers. And we started deploying IPv6, we trained them, we did the consultancy, and in 15 days, the country was jumping from 0% IPv6 penetration to 10%. Okay, so that shows that just one big ISP is starting to move, it's enough. And that was only deploying IPv6 in about 2/3 of the residential customers. In the next few months, they are going to deploy IPv6 in 12 million of cellular phones. Okay, so you can guess how those figures will be able to jump. And again, if you look at different countries, you have South America, Central America, and the Caribbean, and you have the countries that are moving faster on this. And again, you can see the same disparity of figures as we can see in Europe and we can see in other regions like Asia Pacific and Africa, that very few countries go up and the rest still do almost no traffic and so on. I think that's a natural thing, and what we need to try to do is to harmonize the growth in the countries that are still having still low penetration of IPv6, right? I think when one country has one ISP that already pushes for IPv6, naturally, without any additional help, the competitors will need to do that. Okay, so the focus probably should be in the countries that still have no penetration if we want to increase the levels on the region in general. I just mentioned the case for Guatemala. Here you have a graphic. So in, I think it was October 2016, it was no traffic, no IPv6 at all, and then in 15 days they grow, basically in December they grow from 0 to 10%, and it's steady because they are still not deploying the rest of the customers, but that will happen. And we have other significant cases in Latin America, like Argentina and Uruguay, that did similar steps. In very, very few weeks, they jump from 0 to a lot of traffic, right? So that's what we see. An interesting thing is also, if we compare the number of ASs that announce IPv6 in between the different regions, these graphics, well, the previous graphics are from LACNIC. This is LACNIC stats. And those graphics are from RIPE. If we compare the average wall, which is the yellow line, with the different regions, it's interesting that LACNIC, that did a lot of effort in training people regarding the IPv6 deployment, probably has been the bigger effort if we compare the different the different RIRs, the different registries. It's actually the one that has more ASs announcing IPv6, which is almost 40%, right? So compared to the following one, which is RIPE, which is 26%, 27%. And I think that's it. I was told to be quick. I hope I match the time. If there are questions,
just on time. So
just on time.
Just
Thank
on
you
time. Any question for Jody? No. So thank you very much.
Thank you,
Jody. Here's a souvenir. Just express our appreciation.
Thank you.
Thank you very much. Thank you. The next speaker is Fujisaki-san from NTT Japan. Fujisaki is our both old and good friends. Okay, Fujisaki-san, please.
Okay, thank you so much. My name is Tomohiro Fujisaki, working for NTT Japan. And actually, every time I present the IPv6 measurement book about the Japan IPv6 measurement, but this time I asked the present IPv6 progress in NTT. So, yeah, this presentation is about the NTT's IPv6 situation, current situation. Okay. First of all, I would like to introduce about NTT. As maybe many of you know, NTT is one of the biggest Japan carrier. And currently it's a private company, but 30% of stock was held by the government. And NTT has many subsidiaries like this. And for example, the NTT East and West, this is a regional telephone company, and NTT Communications and Dimension Data. This is a long distance and international business sector. And also the NTT Docomo, this is a cellular service, and NTT Data, and this is a system integration service, and many other companies. Maybe we have the 500 subsidiaries. And in this presentation, I mainly explained the service of these 4 companies, because this is the internet-related company. And before that, I'll explain the Japan internet status from the wireless viewpoint and the FTTH viewpoint. And this graph shows the number of subscribers in the wireless service in Japan. As you can see, we have 100 million. Oh, I'm sorry, but yeah, many subscribers, LTE subscribers. And in these numbers, I'm sorry, this graph includes some Japanese character, but yes, this is government data and not English version is not available. But as you can see, we have 3 major telecom wireless carriers in Japan: NTT Group and KDDI Group and SoftBank Group. And the market share is like this. The NTT Group has 40% of the market share, and the KDDI Group about 26%, and SoftBank Group has 24%. This is a wireless service status in Japan. And also, this graph shows the FTTH service. As you can see, we have 3.8 million subscribers in the fixed line service, and in this 3.8 million, about 70% is a FTTH service. And in this 70% FTTH, as you can see, NTT Group has over 50% market share in Japan. Okay, this is the current internet service status in Japan. And next few slides, I'll introduce the NTT IPv6 service. Sorry, and this graph shows not NTT, but the Japanese IPv6 related service history in Japan. And as you can see, around 2000, we started many IPv6 service, and at that time, almost all service is based on the IPv4 tunnel. And around 2010, 2011, NTT East and West started the native IPv6 service, and just recently, Japan major 3 telecom wireless carrier started the IPv6 mobile service. This is a Japan IPv6 service history. And so, as I explained, the NTT East and West, here shows the NTT East and West the IPv6 service. They provided 2 kinds of service. One is IP over Ethernet, and the other is IP using the PPPoE to the consumers. And so actually, NTT East and West do not provide the internet service, but only provide the access service to the ISPs. And so using this NTT East and West IP platform service, many ISPs provide the internet service like the D-Globe, Nifty, and IIJ, and also the NTT Communications Ocean, and so on. Sorry. And as I explained recently, NTT Docomo, this summer, NTT Docomo started the IPv6 Internet Access Service for the consumers. Actually, they have their IPv6 service for their terminals, PCs from the 2011, but this summer they started their IPv6 Internet service for the consumers or their smartphones. And so this is our entities, the IPv6 access service. And I would like to explain one, the application service. This is called the Hikari TV. That is the IPv6 multicast service. Actually, currently, we have over 1 million subscribers for this service, and I think that this is one of the biggest IPv6 multicast network service in the world. Okay, from the next few slides, I explain about the progress and challenges to develop the IPv6 service in NTT. Okay, actually, we have been providing IPv6 service for this about 20 years, so and met many problems. And the first one I have to mention is the last 1 mile implementation. Here, the last 1 mile means the lines between the users and the ISPs. Maybe the many countries have the same kind of problem, and it's so easy to connect using provide IPv6 service on the IPv4 network, but yeah, ideally it should be the native IPv6. So to provide the native IPv6, last 1 mile is one of the very big problem. And at this area, NTT, as I explained, NTT East and West have started to the native IPv6 connection service, so platform service from 2001, and many ISPs in Japan have used this service and provide IPv6 connectivity. And also, this summer, as I said, NTT Docomo and other 3 major Japanese carriers started to the IPv6 service with no additional fee and no special service order by users. So, as I said, our market share is over 50% under the over 50% of the FTTH market. So we have currently we have many IPv6 native users like this. Okay, sorry. And the next topic is the transition of the existing IPv4 users. And this is one big problem, not only the NTT, but also for the all ISPs in Japan. Now, actually, providing the IPv6 and IPv4 dual stack environment to the new user is not so difficult, but we have many IPv4 only users, and how to migrate such kind of users to the IPv6 environment is very big problem. Actually, NTT East and West started their IPv6 service in the 2011, but at first stage, we have no big IPv6 customers. As you can see from this graph, around the 2012 or 2004, the increase rate is not so big. At that time, ISPs provide the IPv6 to the new users or the users who specially ordered to get IPv6. But as many of you know, users don't care which protocol you use. So at that stage, IPv6 users do not increase so much. And so then this is slide provided by the NTT Communications, our ISP section, made a presentation at Vietnam IPv6 Day, and they say that they migrate their existing IPv4 only users to the IPv6 environment without any notification to users. And just now the migration was almost end. And as you see, after the migration began, the total of IPv6 users are increased so much. And this is another stat from the Cisco, and as you can see, the traffic percentage of IPv6 users are increased so much. And this is also the Google data and the traffic to the Google server from the Japanese ISPs. And as you can see, OCN, this is the NTT Communications IPv6 service, and the NTT Docomo service had the rank of them increased. And the last point is applications. So this is the applications I introduced, but this is a local application. And so actually, in that area, Japan is not so active, and many content providers do not provide IPv6 yet. But recently, some ISPs started the, so actually in this APNIC meeting, there are many presentations to the network to the IPv4 only. So in Japan, the same kind of situation occurred, and some ISPs started to provide IPv4 connectivity using the IPv6 network. And this is the service IPv4 as a service in Japan, and the IPv4 over IPv6 service using the DS Lite provided by the NTT Group's Internet Exchange, and also the middle figure, MAP-E IPv4 service using the MAP-E was provided using the NTT's home gateway. This is the Japan application, not application status. So with this kind of activities, Japanese IPv6 traffic is become bigger. Okay, this is almost last slide, and this is summary. Actually, NTT Group has been implementing IPv6 a long time, and not only in Japan, but the NTT Communications provide IPv6 transit service in the all over the world. And also in Japan, IPv6 become popular, but as I said, the content side need more effort. Okay, and this is last slide. Maybe many of you know that actually, IPv6 base spec in ATF becomes the final state, same as the IPv4. So this is very important thing, and so IPv6 needs more development. Okay, this is the end of my presentation. Thank you.
Yeah, it seems to be a very good, successful story of the development of IPv6. Okay, so any question? Yes, please.
Hello, Mr. Fujisaki-san. Yep. I'm Jack from HiNet. On your slide number 31, and I'm curious about the Google traffic. How do you measure it or collect the traffic data?
Slide. Okay, this one?
Yes.
Yeah, actually, Google provides this traffic data to the Japan community. Yes, I got this from Google. Yeah.
Okay, thank you.
Any other question?
Yes, please.
Yes.
Tashi from APNIC.
Yeah.
I think for companies like NTT, and I was going through the list of folks who will be talking about V6 readiness, these things seem to be very companies from rich economies that can afford to deploy it. But when we travel in the regions where ISPs, mobile operators are in the poor economies, what they say is, yes, they would like to do it, but then the extra cost that's involved where vendors tend to take advantage of that fact. Like to enable IPv6 PDP in mobile network, what I heard is vendors are now started charging people for that. And then last mile equipments that don't recognize V6 ether types, so they would have to replace those. So what would your advice be to those operators who for whom it's not just a technical challenge, for whom it's also a financial challenge?
Yeah. So In that sense, it's a little bit very difficult question, but so in Japan, actually, we have the IPv6 promotion body, including the government and industry and academia and so on. So and discussed how to develop the IPv6, and so. Yeah, actually, yes, and financially, problem is very big, but in that sense, big companies implement IPv6, and even in Japan, the small company or small ISPs do not implement yet. So yeah, this is not the answer, but yes, thank you so much.
I can probably try to provide some guidance here as well. I agree that a few years ago, let's say 10 years ago, if you have routers or equipment that don't have IPv6 capabilities, or that they have IPv6 capabilities but they do in software instead of hardware, then implementing IPv6 can mean a big cost for an ISP. If an ISP keeps regularly updating their equipment and they replaced the routers maybe 5 years ago, all the vendors 5 years ago had support for IPv6. So I am not saying the cost will be zero, but it will not be a significant cost. And what you need to consider is that maintaining IPv4 actually costs much more than moving to IPv6, even if it means some cost.
Yes, I understand. Okay. I'm not talking about the core network per se. It's more, the challenge is more on the access network. ISPs, even in poor regions, ISPs do have routers that are capable of V6, no extra cost. They'll enable it, technically not so difficult to do. But the access network, they have invested so much in building those, you can't just replace it overnight. Mobile is also an access network, whatever said and done. FTTH is an access network.
But I don't...
You have MSANs and OLT IPD slams that don't recognize V6 ether types. So how do you do that?
I really think that most of this equipment is IP agnostic most of the time. It depends on the technology.
Exactly, that's what we would assume, but these are real cases. We would assume your lower layers would be agnostic to your upper layers, but it's not the case. That's what many people have found, because we tell them that before you deploy, maybe you should do some assessment of the infrastructure that you have, whether it can support or not. So what we are finding weirdly is that layer 2 devices seem not to forward V6 at the time, meaning they now have to replace those devices.
I have been in situations, for example, having even in simple wireless access points, not allowing link local multicast, which means that IPv6 cannot get auto-configured. That's a bug. That's not an IPv6 problem, that's a bug. Or I have seen a contract of a cellular ISP acquiring, I think it was release 9, I don't remember right now, equipment, not asking for IPv6, but that release of 3G was mandating IPv6. So that's a contract break. You are purchasing a given release of software for 3G, and it's not actually applying the complete set of features that must support. So I think it's difficult to say in general, but case by case, I think there are ways to tell your vendor, you cheated me. You provided me equipment that has some bugs or is not committing the release or what the release is expecting.
Okay, for the sake of time, you have a question? Short question, okay.
Okay, I am David Huang, come from React Games. We have office in Tokyo. The ISP should be OCN or Sony. We got an issue is, we have video IP, but the routing is fake. We cannot trace to Google DNS. You just block in Japan. We cannot go outside. We test the Google, we test the Taiwan video IP, but it's not connected. You just block. Yeah. So you say the ISP provide the video service, but the routing is fake. Yeah. When talk with the ISP talk to us said, you have the other service. You need other service for V6. Yes. So this issue is no fee, no other request, but the default video V6 service is not usable. Yeah. So this is depend by the ISP or depend by the NTT. We don't know where the issue happened. Yeah. The routing is not work, really.
Yeah,
Yes.
for the sake of time, maybe you can discuss after
Yeah, please.
as a
Discuss more
break,
Thank you
as
so
a
much.
coffee
Yeah.
break. Okay. Okay.
Thanks so much. Yeah.
Okay. Thank you, Fujisaki-san. Thank you.
Thank you.
The next speaker is from Zhonghua Telecom. Mr. Jia Wei Zhen is going to talk about the IPv6 progress and the challenges in Zhonghua Telecom. Jia Wei, please.
And Chairman and all IPNIC friends, good evening. My name is Jia Wei Zhen from Zhonghua Telecom. Today, I'd like to talk about the IPv6 progress and the challenges in Zhonghua Telecom, and sharing some IPv6 deployment experience. And at the beginning, I would like to briefly introduce the Zhonghua Telecom. Okay, the Zhonghua Telecom is the leader of the ICT companies in Taiwan, with a high-quality ICT infrastructure and networking capability, including broadband and mobile network services. Zhonghua Telecom's broadband subscriber market share is about 74.3%. The mobile subscriber market share is 37.3%. This page shows the IPv6 measurements in Taiwan. According to the APNIC statistics, the Taiwan's IPv6 user ratio is only 0.51%, and the Taiwan's IPv6 ranking in the world is in the number 63. Well, this result is expected because all service providers in Taiwan, they do not provide the commercial IPv6 service. The OPEX and the CAPEX are two important factors that the service provider they need to take into consideration when they deploy the IPv6. For Zhonghua Telecom, well, the Zhonghua Telecom, you can see the IPv6 ratio is still low, but you can see it's the IPv6 deployment ratio for Zhonghua Telecom is increasing. Why Zhonghua Telecom needs IPv6? There are three major reasons. IPv4 addressed erosion. Business continuously growing. And the innovation service in the future, especially the IoT service in the mobile networks. Due to these reasons, Chunghwa Telecom decided to deploy the IPv6 since 2008. In the past years, Chunghwa Telecom acts as a partner in the government broadband network and efforts engaging the IPv6 research and development. HiNet is the first one service provider that obtained the ISP logo in Taiwan. Our HiNet has launched the dual stack service in the end of 2011. In this year, we are focused on deploying the public wireless LAN and the LTE IPv6 trial run. And we are planning the 4G LTE are planning to commercial service in 2018. This slide shows illustrates the Chunghwa Telecom's network architecture. In addition to the broadband and the mobile network, our backbone is IPv6 ready. We have the international peering with the major service provider in the worldwide, including the AT&T, Verizon, even the NTT. In the domestic peering, we have the domestic peering, including the TWIS, GSN, and etc. In the IDC data center, our IDC data center is IPv6 ready, and there are some enterprise customer are in our IDC data center. The other IPv6 related dual stack service, for example, high channel, email, and even DNS, they are all IPv6 capable for our customers. Okay, yes. Well, this page shows the IPv6 service in Chunghwa Telecom's HiNet. It's worth to mention that our FTTX dual stack service has launched the 4 city default service in Taiwan, including Hsinchu, Taoyuan, Taichung, and Kaohsiung. We have provided the residential and the business type service. The difference between these two types is depends on if you use the PVPoE or not. Chunghwa Telecom is also provided the IPv6 testing service in Taiwan, and we provide the testing capability, including the IPv6 core, IPsec, DHCP, and the extra. We think IPv6 is still a technical-driven technology. It's not a service-driven technology. So we would like to discuss some technical issue from this slides. And in the case 1, we want to study the path diversity. As we understand, both IPv4 and IPv6 are network layers protocols. Well, the routing differs between IPv4 and IPv6 may result on equal quality of experience for our customers. Well, this problem will be improved the user's experience when the IPv4 and the IPv6 coverage are equal extent. We have tested the measurement Alice top 100 website, including the Google, Yahoo, and the restaurant. And some of these websites are dual stack. Some of these websites are IPv4 only. So we test dual stack and the IPv6, IPv4. According to our test result, we think about 30% dual stack is faster, about 40% IPv4 is faster. But it's almost 90%, 19%. The test host spends less than 1 minute to open the website. The second case, CP IPv6 issues. Well, there are two different types of the CPE. Customer-owned AP and ISP provide home gateway. The problem is not all CPE supports IPv6, especially the customer-owned. The IPv6 capability, they need to support the Wi-Fi, PVPoE, the related function. And for service provider, replacing or upgrading the home gateway is a challenge, in particular for large networks. But we think this problem can be solved. The plan earlier, allowing aging the deploying of IPv6 with regular refresh cycles, may reduce the CapEx for the and any new equipment purchase is IPv6 capable. Well, in the third case, we found some antivirus software maybe have some connection problem. Some antivirus software will maybe modify the packet into the editing the extension header. This may cause the router may not recognize this packet. It will cause the connection fails. And some antivirus firewalls, their default policy will block all incoming and outgoing IPv6 traffic, which means the IPv6 host cannot finish their auto configuration process. And in the case 4, we are talking about the mobile network. We think there is a problem called IPv6 unsolicited traffic. Unsolicited traffic means the traffic is not initiated from yourself. Because the LTE IPv6 do not have NAT or firewall to blocking external networks. The IPv6 NAT will broken the end-to-end communication. In the IPv6 network, it's a problem. May cause the cybersecurity risk. Well, there are many solutions to solve this problem. In General Telecom, we are still evaluate the firewall security policy on the border. In that case, we found some, not all vendors provide the default dual-stack APN setting in Taiwan. There are many brands in Taiwan. The users are not familiar with the operation. Here is an example shows the HTC cell phone to setting the dual-stack APN. As you can see, there are 6 steps. It's not easy for everyone. And we are to solve this problem. We encourage our UE partner. They made their new phone in 2018 should initial the dual stack APN by default. For some old type user equipment, they may upgrade the IPv6 or the OTA for old cell phone. Well, we think the IPv6 deployment comes with its own challenges. And with the upcoming IPv6 commercial service, we believe the Taiwan's IPv6 user ratio and the ranking in the world will be increasing in the near future. For service provider, the CP and the UE are critical role for IPv6 deployment. Deployment is the IPv6 is a service provider's decision, not a customer's decision. Well, that's all my presentation. Thank you for your attention.
Any question? Okay, thank you very much. Thank you. The next speaker is Ms. Cui from APNIC. She's going to talk about the measurement for IPv6 deployment in VLAN. Please.
So good afternoon, everyone. So my name is Thuy. I work for Vietnam International Information Center. And thank you very much. And I'm very happy to see that IPv6 deployment ratio is getting better. And each time we meet each other, we talk about IPv6 deployment, and we see that it is better and better. And I also would like to show my admiration for TWNIC for their endless effort in IPv6 promotion. So in Vietnam, actually we share quite many times about our national IPv6 action plan. So you may know that in Vietnam we have a national IPv6 action plan, and at that time we are in the final phase of our plan. And our purpose is to promote IPv6 deployment overall on every sector. For example, for ISP, for content provider, for mobile operator, governmental entity, and lastly is to provide IPv6 services to end user. About the IPv6 promotions, policies, and activities, I think that the same with many other. We do the V6 promotions through public event and the training courses, and through the cooperations activity. In Vietnam, we have a national IPv6 task force. This task force is led by a Prime Minister of Ministry of Information and Telecommunications, and APNIC, as an APNIC, we are on standing committees in the task force. In 2017, seemed to be a successful of IPv6 deployments in Vietnam. We organized 3 successful courses for IPv6 training for governmental entity, and the 4th will be organized in the next month in Ho Chi Minh City. And we also organize several events for IPv6 deployments. I want also to mention some measurements on IPv6 deployments in Vietnam at the moment. If you see on the screen, you could see that at that time, Vietnam has a quite good IPv6 deployment ratios. In general, measurements by APNIC lab, we have the deployment ratio around 9%, and for the end user, Google statistics said that there are over 4 million IPv6 Vietnamese users. About the infrastructure, I mean the critical infrastructure, .vn DNS system supported IPv6 since 2006, and at the moment, the DNS system works quite well with IPv6. About VNIX, our national internet exchange point. In Vietnam, actually there is only IX. VNIX is only IX now in Vietnam. We connect almost every ISPs in Vietnam. And VNIX supported IPv6 since 2006 with quite many large IPv6 connections. However, as you can see on the screen, the IPv6 traffic is very small. If the traffic outside, I mean from Vietnam to overseas, is quite good, but the V6 traffic, domestic traffic is still very low. That is because we lack of content provider who already supports IPv6. About the network, if you see in the screen, you can see that some network which has good IPv6 capables from Vietnam. You can see the among them FPT and VNPT is the two first ISPs who offer IPv6 commercial services to end user. And in fact, VNPT and FPT is also two largest ISPs in Vietnam. When they deploy IPv6 commercial services, the overall IPv6 deployment ratios in Vietnam is rising very fast. And very fast. And IPv6 promotions policies in our legal document is also a good result that we have at the moment. On some legal document, we already have IPv6 promotion policy. The first one is the decree number 72, which is published in 2013. In this decree, the Vietnamese government says that IPv6 deployment is a high priority of internet in Vietnam. And recently, IPv6 promotions is mentioned in some recent legal documents, such as the plans for broadband telecommunication infrastructure to 2012, and the National Telecommunication Development Plan to 2012 is also mentioned about IPv6 deployments. And the last thing I would like to share is about issue that we need to come over. Actually, besides the good result, IPv6 deployments in Vietnam still have quite many issues that need to be resolved at the final phase. The first thing is that the IPv6 deployments of government agency is very low at the moment. I think it is a very difficult, very different with Taiwan, with the case in Taiwan. I saw that in Taiwan, the government agency will be the first entity to deploy IPv6. But in Vietnam, the private sector that means the ISP, they start first. They provide IPv6 services to customers. But the governmental agency, the IPv6 deployment ratio is still very low. That's why the IPv6 task force focus on the governmental agencies. And besides the governmental agency, we also would like to promote IPv6 deployments in content providers and promote the other ISP to provide IPv6 services to customer. And particular in this year, we will have a working schedule to Viettel. In Vietnam, Viettel is the second largest ISP, but they do not provide the IPv6 commercial service yet. So in the next October, we will have working to Viettel to ask them to provide the IPv6 commercial service to customer. Such as like FPT Telecom and VNPT. Yeah, that's my presentation for today. And thank you very much for listening to me. Yeah, thank you.
Is there any question? No? Thank you very much. Thank you. The next speaker is from India, Mr. Ajay Kumar. So he's going to talk about the Indian IPv6 measurement. Ajay, please.
Thank you very much for inviting me, and it's my pleasure to be present Indian IPv6 status or India IPv6 measurements. Recently, I am working with Mumbai Internet Exchange. Earlier, I was part of the National Internet Exchange, who was part of that government program, who was promoting the IPv6. Okay. Thank you. So, as per the Cisco lab report, right now we are 7.2% IPv6 out of 10, and the 44% prefixes are already deployed in IPv6. As far as the content, if we see in India, 59% content is in IPv6, but those content are the global content. And 21% users are on IPv6. So in India, Department of Telecom, Government of India was preparing to have IPv6 in all networks which are present in India. In 2005, a private internet service provider, SIFI Technologies, has started the rollover and testing the IPv6. Indian registry, NIR, is giving IPv6 virtually free. The recent Reliance Jio has launched his services on IPv6, and within few months, they got 100 million plus LTE customer on IPv6. If we see the Asia Pacific, 15 countries or economies, India is right now #1. NIXI, the first internet exchange, has done a lot for promoting IPv6. NIXI has done 10 workshops with help of APNIC for doing the awareness. NIXI has done the setup test bed for doing testing. After that, they have moved all internet exchanges node on IPv6. The Mumbai Internet Exchange is also on IPv6. That is the largest internet exchange in India. And 50% peers are on IPv6. Awareness, we have hosted seminars, different departments, different organizations like NICSI, Department of Telecom, ARNET, BSNL, all have done the awareness programs, trainings. Government of India has impaneled many IPv6 vendor who are supporting and giving consultancy service for implementing IPv6. Regarding the CCTLD, the .inc CCTLD, all servers, all infrastructure has been migrated to IPv6. Those are all on dual stack. The DNS server can take the queries on IPv4 as well as IPv6. Like Vietnam, in India also, government has taken initiative for promoting this IPv6. They have developed the roadmap number 1. On that, they have identified the task force, working groups, awareness programs, empanelment of consultants, posting of personnel in all state of government, all state of in India, and deploying the test bed. Then they have released the second roadmap. The Telecom Policy 2012 was one clause for implementing the IPv6, that achieving substantial transition to new IPv6 in the country in a phased and time-bound manner by 2020, and encourage an ecosystem for provisioning of significantly large bouquet of services on IPv6. As per the policy roadmap version 1, they have given the timeline that all major service providers will offer IPv6 services by 2012 onwards. And all government websites, like you have seen, and that Vietnam, the government is behind on IPv6. So they have also included that all government sites should be on IPv6. And constituting of the task force. And task force was headed by the Secretary of the Government of India, Department of Telecom. And they have involved all parties, all stakeholders from the industry, private, and academics. So as per the second roadmap, version 2, they have revised the timeline, because the first roadmap was saying that we will be doing in time-bound manner by 2020, and they have given the timeline by 2012 or 2011 onwards. So based on the review, they found that still IPv6 has not been done significantly, so they have revised timeline for each sectors, for service provider, for content provider, for equipment manufacturing and organizations, government organization. After that, they have revised the timeline, because while reviewing it was found that these timelines have been passed and still IPv6 has not been implemented. So as per the latest timeline, from 1st January 2017 onwards, all equipments which are coming to India, including mobile, routers, switches, network equipments, all should be IPv6 compliant. And for the government organization, whatever the timeline has been given, everyone has to comply that. After that, if any problem is coming, government anytime can take decision or penalty, that is the government purview. So they have, for standardization and testing, one government organization, TEC, has signed the MOU with IPv6 Forum, and they are also testing the equipments which are being made in India and giving the certification for IPv6 in India, we have 35 states. The central government has asked each state to nominate IPv6 nodal officer. And all 35 states has nominated one nodal officer. If any problem is there, that nodal officer can be reached. And in India, we have 92 departments of ministries. There also, the central government, the Department of Telecom has asked, please nominate the nodal officer. From all the departments, one IPv6 nodal officer has been appointed. As per the APNIC lab, around 52% the IPv6 capable network is there. If we see the top 15 enterprise with IPv6 deployment in India, the Reliance Jio is on number 1, who has made us proud for promoting IPv6 and deploying IPv6. And if you see the top, all are the mobile operators. Reliance Jio, Bharti, Idea, Vodafone, BSNL. These all are the mobile operators. As well as they have different AS number and different departments for the internet service providers. If you see on this list, the first organization, CIFI Technologies, they have done everything and now they are not on the top. Thank you for listening. I will be happy to take the questions, if any.
Okay, any question? No? Thank you, Ajay. Thank you. The next speaker is Mr. Genda Cai from TDMNIC. He's going to introduce the Taiwan IPv6 readiness measurement. Genda, please.
Okay. Thank you, Professor Chen. And good afternoon, everyone. My name is Genda Cai from TDMNIC. Today I will present Taiwan IPv6 readiness. Okay. Here is my outline. So the first one is status of IPv6 deployment in Taiwan, include government, academia, and the SPs. And then status reports for outcome of the criteria of IPv6 readiness measurement. And the third one is my conclusions. Taiwan government has a project to help governmental agencies in Taiwan upgrade their network, government network, to support IPv6. And totally 1,210 government agencies join the project and follow the project to update their servers and the network. So these government agencies plan or propose in this year and according to the project, the program, and start to upgrade their network. Okay. About Taiwan IPv6 deployment in governmental agencies. We can observe the S number 4782 government service network. And this graph shows the IPv6 user availability in this S number, stand for government service network in August, arrived at 16.14%. And there's a public Wi-Fi service hotspot in Taiwan. Some hotspot of Taiwan government private Wi-Fi service, its name is iTaiwan, have supported IPv6, and we are expanding this IPv6 this year. So we have 3 stages. for prepare this hotspot to upgrade to support IPv6. Stage 1, service trial, is implemented in the building of Ministry of Transportation and Communications. There was upgrade 20 hotspots in 2015. And stage 2, we call it small scale service, is implemented in totally 321 hotspots on sightseeing spots and transportation stations, train stations in 2016. And stage 3, this year, we call it large-scale service. It planned to be implemented in 5,965 hotspots in Taiwan. The coverage rate is estimated to be nearly 73 of hotspots to support IPv6 in this year. Okay. And here shows the Taiwan IPv6 deployment in academia. So we can see the graph. IPv6 traffic in Thailand grows up, and the traffic of Taiwan in IPv6 of Thailand is around 3.6 gigabit per second. 32% of its IPv4 traffic. And we measure 3 well-known type servers in Taiwan: web server, email server, and DNS server. So these 3 type servers grow up gradually. And we have 3 common measurement criteria. The first one is IPv6 BGP advertisement. So we can see the graph. The ratio of IPv6 BGP advertisement in August this year has arrived at 38.34%. And the second is IPv6 service availability. The data is collected from Alexa top 1 million websites. The ratio of IPv6 service availability in August this year has arrived at 15.14%. And the third one is IPv6 user availability. The ratio of IPv6 user availability in August this year is around 1.39%. So we can see the small increasing in August. We think it's because of Taiwan had started to support IPv6. Okay, the following is my conclusion. The ratio of the 3 common measurement criteria: IPv6 allocation and BGP advertisement, service availability, and user availability, we measure that grow up in Taiwan recently. The customers of ISPs still need to be encouraged to apply the IPv6 as a service in Taiwan because there is no any ISP in Taiwan provide IPv6 as a network by default. So if you are an end user, you want to use IPv6, you need to apply IPv6 as a service to ISP. Okay. And finally, the large scale of the Taiwan governmental public Wi-Fi service, its name is Taiwan, we will support IPv6 and this year. Okay. And we will promote this IPv6 as a service to people in Taiwan. Okay, thank you for this. You are listening. Thank you.
Any question? Thank you, Genda. Thank you. Thank you for your presentation. So please join me to thank all the speakers once again. Okay. And I also would like to thank all the audience for your participation. And this session is closed. Thank you very much. Thank you. I'd like to invite all the speakers.